Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have a topic of 19.3, chapter number 19, atomic spectra. Uh, this is the first topic according to our smart syllabus in this chapter, and this topic is Bohr atomic model of hydrogen atom. Okay. In 1913, Danish scientist Niels Bohr proposed a theory of hydrogen atom which contains a combination of ideas for the classical physics. Planck's quantum theory means this atomic model is the combination of classical and quantum physics. So this atomic model is also called semi-classical model. Okay, semi-classical means part of it is classical and the remaining part is quantum physics. Okay, Einstein photon theory of light and Rutherford model of atom. Okay, Bohr's model of hydrogen atom contains some classical feature as well as revolution postulate that could not be justified within the framework of classical physics. The Bohr model can be applied quite successfully to the hydrogen atom. Okay, now look at the postulates of the Bohr atomic model. Okay, the first postulate is when an electron revolves in its own shell, when an electron revolves in its own orbit on shell, it neither gains energy nor lose energy. It neither gains energy nor lose energy. Okay, means the energy of electron is constant. When it revolves in its own shell, its energy will remain constant. Okay, but when electrons gains energy, whether heat energy, light energy, or electrical energy, gains energy, it will jump from lower shell to higher shell. Similarly, when electron lose its energy, the electron will jump from higher to lower shell. Okay, means when the electrons gains energy, it will move far away from the nucleus, and when electrons gains energy, it will move closer to the nucleus. Okay, so and when electron is revolving in its own orbit, it will neither gains energy nor lose energy. Okay, these are the two postulates. The third one is the angular momentum of electron is quantized. So the angular momentum is equal to n h cut. This is called h bar, or this called h cut. This h bar is equal to h by 2 pi, where h cut is equal to h by 2 pi. H is a Planck's constant, and h bar is also Planck's constant divided by 2 pi. Okay, so it is said in this postulate that the angular momentum should be quantized. So this n is principal quantum number. For the first shell, the angular momentum will be 1 h cut. For the second shell, it will be 2 h cut. For the third shell, it will be 3 h cut. For the fourth shell, it will be 4 h cut, and so on. It means the angular momentum will be quantized, will be integral multiple of natural numbers. Okay, so the angular momentum of electron in a specific orbit will be always quantized. Okay, the hydrogen atom or any other atom will have discrete orbits, will have discrete, or quantized orbits. Okay, each and every orbit will be discrete. Irrespective of this discrete orbit, the region is called the forbidden region. Okay, now these are the different postulates given by the Bohr. Now suppose we have an electron revolving around the nucleus. Okay, so according to this postulate, the angular momentum of electron will be quantized. It means that angular momentum will be equal to nh divided by 2 pi. Okay, and we know that angular momentum is rp, so rp is equal to nh by 2 pi, and we know that p is equal to mv, so rmv is equal to nh divided by 2 pi. Okay, now divide mr on both sides, so v will be equal to nh divided by 2 pi mr. This label is equation number 1. Okay, now we have velocity of electron in a specific shell, that is v is equal to nh divided by 2 pi mr, where r is the radius of the orbit. Okay, now look at here, electron is negatively charged and the nucleus is positively charged. Okay, now there is a Coulombic force between the nucleus and the electron, and this Coulombic force bound the electron, and this Coulombic force compelling the electron to move in a circle. It means this Coulombic force provided the centripetal force. So Coulombic force provided the centripetal force, and we know that the Coulombic force is equal to k q1 q2 divided by r square. So the charge on electron is the charge on proton is E, and the charge on electron is E. Both have the same charge. Proton has 1.6 into 10 power minus 19 coulomb charge, and the electron have the same charge, that is 1.6 into 10 power minus 19 coulomb. Okay, now what is centripetal force? mv square by r. Okay, now here r and r will be cancelled, so it will be ke square divided by r is equal to mv square. So putting the equation of putting equation 1 here in this equation, we called it this equation as equation number 2. So putting equation number 1 in equation number 2, we get, okay, now put this equation here. So what will we will get? So look at here, look at on another page. Okay, now the equation 2 is ke square divided by r is equal to mv square. Okay, now if we put equation 1 here, so it will be m into n square h square divided by 4 pi square m square r square. Okay, now what will be cancelled? Here m and m will be cancelled, r and r will be cancelled, so what will be left? So look at here, shift this r to this side, so it will be r is equal to n square h square divided by 4 pi square m ke square. This is the radius of the orbit in hydrogen atom. Okay, now look at here this equation. Look at here this equation. Here h is a constant, pi is a constant, m is a constant, k is a constant, e is a constant. Okay, all these are constants. If all these are constants, so I label them as r naught. I label them as r naught. So the equation becomes r is equal to n square r naught. So first we will talk about r naught. So what is r naught? R naught is equal to h square divided by 4 pi square m k e square. Okay, now we know that the value of h, that is 6.62 into 10 power minus 34 joule second. We know that the value of pi, we know that the value of mass of electron, we know that the value of Coulombic constant, that is 9 into 10 power 9. We know that the charge on electron, that is 1.6 into 10 power minus 19 coulomb. So if you put all the values, we will get 0.53 angstrom, 0.53 into 10 power minus 10 meter. So this R naught is called the first Bohr radius. Okay, now look at the equation. Look at the equation. The equation is equal to n square r naught. Okay, what is r naught? R naught is 0.53 angstrom. Okay, if we want to find the radius of the first orbit, so we will put n is equal to 1, so it will be 1 r naught. If I want to find the radius of the second shell, so I'll put n is equal to 2, so it will be 2 square r naught, so it will be 4 r naught. Okay, if I want to find the radius of the third orbit, so I should put the value of n as 3, so it will be 3 square r naught, so it will be 9 r naught. Another will be 16 r naught, another will be 25 r naught, and so on. So these are the discrete orbits. So this was the last postulate, that the Bohr stated that the radius of each atom will have quantized orbits. Means either 1 r naught is allowed, either 4 r naught is allowed, or 9 r naught is allowed, or 25 r naught is allowed, and so on, irrespective of these orbits that are not permissible in hydrogen atom or any other atom. So only these radii, these orbits are allowed in hydrogen atom. Irrespective of these orbits, the other orbits are not allowed. Okay, now come towards another thing, which is equation number 2. So okay, forget about equation number 2. First we are talking about the kinetic energy. The kinetic energy is equal to half mv square. Okay, now let us take equation number 2. So we know that equation number 2 is k e square by r is equal to mv square. Okay, now divide m on both sides, so v square will be equal to k e square divided by mr. Okay, now from equation 2 I'll write here equation number 2, k e square divided by r is equal to mv square. So divide m on both sides, so it will be k e square divided by mr is equal to v square. So this is the equation for v square. This is the equation for v square. So put this v square in the equation of kinetic energy. So what we will get? Look at here. If we put the value of v square here, so we will get half m k e square divided by mr. Okay, so m will be cancelled here, so the kinetic energy of electron will be k e square divided by 2r. So if the MCQs comes in eta, that if the electron jumps from lower shell to higher shell, what is its kinetic energy of electron? Increase, decrease, or remains the same? So the answer should be decrease. Why decrease? Because if an electron jumps from lower shell to higher shell, we know that the radius will be get increases. If the radius increases, its kinetic energy will be decreases, because both are inversely proportional. So if the electron jumps from lower to higher shell, radius will increase. If the radius is increased, kinetic energy will be decreased. So decrease is the correct option. Okay, this is the equation for kinetic energy of electron in a specific shell. Okay, now talk about the potential energy. So look at here. Now we are talking about the potential energy. Potential energy is equal to QV, and we already studied in chapter 11 electrostatic the electric potential due to a point charge, that is minus KE divided by R. So putting the value of V here, so it will be minus KE divided by R, so it will be minus KE square divided by R. Okay, now the potential energy, the equation of potential energy will be minus KE square divided by R. Okay, now if the question comes in MDK test, that if electron jumps from lower shell to higher shell, higher shell, then what is the potential energy? Increase, decrease, or remains the same? So look at the equation. If electron jumps from lower shell to higher shell, it means that the radius will increase. If the radius is increased, the potential energy will get decreased. And if anything is decreasing in minus, because the potential energy is negative here, if any value decrease in case of minus, so it means that actually it is increasing. So the answer is increased. So if any electron jumps from lower to higher shell, its potential energy will get increases. Okay. So this question, this is the MCQ's question. Now come towards the total energy. We know that the total energy is equal to kinetic energy plus potential energy. Okay. What is kinetic energy? Kinetic energy is equal to ke square divided by 2r. What is potential energy? Minus ke square by r. Okay. Now take the LCM as 2r. So the LCM is 2r. So kinetic energy is ke square minus 2ke square. Okay. So the total energy is minus ke square divided by 2r. This is the total energy of electron. Okay. Now we found the total energy of electron in a specific shell. Okay. We already found the value of radius in the previous question, in the previous equation, that r is equal to n square s square divided by 4 pi square mke square. This is the value of radius. So putting the value of radius over here, so we will get total energy is equal to minus ke square divided by 2 into 4 pi square astaghfirullah n square s square divided by 4 pi square mke square. Okay. Now putting the value of radius over here, so we will get shift this double division to up. So it will be minus ke square into 4 pi square mke square divided by 2n square h square. So what will be cancelled? Look at here. What will be cancelled here? So look, 2 and 4 will be cancelled, and it will be minus 2 pi square k square e power 4 m and divided by n square h square. Okay, this is the final equation of the total energy. Now look at here. Pi is a constant, k is a Coulomb's constant, charge is constant, mass is constant, Planck's is constant. So all these are constants. If all these are constant, I label them as E naught. So E naught is equal to 2 pi square k square e power 4 into m divided by h square. So I label them all these constants as E naught. So first, putting the value, putting E naught here. So the equation for the total energy will be E naught divided by n square. This is the equation for energy. Now I want to calculate the value of E naught here. So look at here. We know that the value of pi, which is 3.14. We know that the Coulombic constant, that is 9 10 power 9. We know that the value of charge, that is 1.6 in 10 power minus 19 coulomb. We know that the mass of electron, that is 9.11 in 10 power minus 31 kilogram. And we know that the value of Planck's constant, that is 6.62 into 10 power minus 34. So if you put all these values, we will get 13.6 electron volt. This is the energy of electron in the first shell. Okay. Now if I want to calculate the energy in the first orbit, so I should put n is equal to 1 in this equation. So if I put n is equal to 1 in this equation, so I'll get energy in the first orbit, that is E is equal to minus 13.6 electron volt divided by 1. So it will be minus 13.6 electron volt. If I want to find the energy of second shell, so I should put n is equal to 2 in that equation. So we will get E is equal to minus 13.6 divided by 4. So it will be minus 3.4 electron volt. If I want to find the energy in the third shell, so I should put n is equal to 3 in that equation. So I'll get 13.6 electron volt divided by 9. So it will be minus 1.51 electron volt, and so on. So these are the energies of electron in the different orbits. Okay. Now we are discussing that Bohr atomic model can explain Bohr atomic model according to the classical physics. If we talk about the classical physics, if we talk about the modern physics, the uncertainty principle says that we cannot find the position and the momentum of electron at the same time. So here the Bohr cannot explain the uncertainty principle. So here that is the main drawback in the Bohr atomic model. And Bohr atomic model is only valid for the single electron system, means for the hydrogen atom. For the other atom, it is not valid. And Bohr atomic model cannot explain the classical physics also, because in classical physics, we know that when a system is accelerated, when a system is accelerated, it will gain energy or lose energy. It will gains energy or lose energy. Any system, whether it is if it is accelerated, so it will must gain energy or lose energy. But here Bohr said that this electron is moving in its own orbit. It neither gains energy nor loses energy. Means Bohr said that the energy of this electron is constant. But according to classical physics, this electron is accelerated. This electron is accelerated. If this electron is accelerated, so it should gain. If this electron is accelerated, for example, it is gaining energy. If this electron is gaining energy, so it will move far away from the nucleus. And if it is continuously gaining energy, it will continuously moving far away from the nucleus. And a stage may come that it will escape from the nucleus. So no such hydrogen atom, the structure of hydrogen atom can be possible, because according to Bohr atomic model, when an electron gains energy, it will move far away from the nucleus. So no such type of structure of hydrogen atom can be possible. For example, if this electron is accelerated and lose its energy continuously, so if it is lose its energy continuously, so it will move towards the nucleus, and it will move towards the nucleus, and it will collapse on the nucleus. So no such type of structure of hydrogen atom can be possible. And Bohr cannot reply to these reservations of classical physics. So this is the main failure of Bohr atomic model, that it cannot explain the classical physics. So the Bohr jumps to the quantum physics, that Bohr said that the angular momentum of the electron is quantized. So he cannot explain the classical physics very well. So this is all about Bohr atomic model. If you have any queries, any question, so you can comment on this video, and you can WhatsApp in your group. Okay, take care. Allah Hafiz.